Alright, at a sand and gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. So, we have a cone, and sand is like falling onto that. Okay, we keep contributing to the size of that conical pile. At a rate of 10 cubic feet per minute. So what is that? Not the area of the cone, it's cubic feet. Volume of the cone. And it's the rate. So the volume doesn't equal 10, but dV dt equals 10. Okay? The diameter of the base of the cone is approximately 3 times the altitude. So, here's my altitude. We'll call that A. And the diameter is approximately 3 times that. So what am I going to label my diameter? 3A. If we want, you can write a little equation over here. We'll see if we need it. But the diameter is 3 times the altitude. At what rate is the height of the pile changing? Now, we already called the height of our pile A, so we'll just use it as at what rate is the altitude of the pile changing. So what are they looking for? dA dt. When the pile is 15 feet high. So what's that 15? A, good. Okay. So, really nothing is constant at all here, other than the relationship between the diameter and the altitude. The diameter is always 3 times the altitude. But we've got some insight as to, hopefully, what equation we should be working with. If we know dV dt, what equation about a cone should we be interested in? Volume. Do you guys know what that is?
1/3 times radius.
You know what? That's a point for Dan.
Yeah. That's 2 now.
So, and actually, do we want to go back and make our AH?
Yeah.
Let's just do it. Let's just do it. They called it altitude at first. Then it was H. There. Now it's consistent. Okay? Here's the issue. If we differentiate this right now, we're going to have a dV dt, we're going to have a dr dt, and we're going to have a dH dt. Okay? And the dH dt is fine. We want that because that's what we're looking for. The V is fine because we do know dV dt, but I'm not sold on keeping the R there, and I'd rather get rid of it from the get-go because I have no, dr dt hasn't even come up yet. Okay? R hasn't even come up yet. But what do we know about R, Aaron?
R is equal to 3 halves H.
Alright, before we get there, rather than going to the diameter, use 2R. And so then we can solve for R, dividing both sides by 2. And like Aaron said, R equals 3H over 2. And if that is what R equals, I can substitute that in for R before I differentiate so that I don't have, thank you, so I don't have a dr dt issue to worry about, because I don't want 2 unknowns, I only want 1 unknown. So I'm going to take my volume formula and I'm going to get rid of the R and replace it with 3 halves H. And then I'm going to clean up the original equation first. So What's 3/2 squared? 9/4. I'm gonna take my time with this, but some of you will be able to skip steps a little faster. So 9/4 8 squared. And then when you multiply this whole thing out and clean it up, 1/3 times 9/4 is 9/12, yes? And 9/12 reduces to 3/4. I have a pi, and I have h to what power? Third. Good. So, I haven't differentiated anything yet. I've just kind of gotten rid of the fact that I had too many variables in there. Not too many, but you want less, and you want to cater to the rates of changes that you know or that you are actually looking for. So now I can differentiate. So on the left-hand side I have dV dt. Oh, and what's going to happen on the right? Power rule, which is going to make what? You got to drop that by degree of 1 though. H squared, and then your dH dt. Good. So we do know that dV dt is 10. What's our h? Right, we're doing all of this at the moment that h is 15. And we're looking for dH dt. I differentiated with the power rule, so I brought my 3 out in front, made it 9/4, and then the pi h got dropped to a squared.
Oh, so it wasn't a product?
It was not a product rule because there's only one variable there.
Okay.
It would have been a product rule if I had kept that r there, which I guess for that reason it also would have been not pretty. On top of the fact that we don't know dr dt or anything about r. And then from here we just have to simplify. So I would first probably multiply by the reciprocal here. Multiply by 4/9 on both sides. That's going to make 40/9 equals 225 pi dH dt. And then when I divide both sides by 225 pi, that 225 pi just goes in the denominator. And then I can reduce the 40 and the 225 are both divisible by 5. So that would become an 8. What would that become? 225 divided by 5. What is it, 45? So 8 over 9 times 45 pi. Oh, 9 times 45?
Calculator, maybe?
Nope. Oops. Just a little... Aaron was right, but I wanted to just do a little multiplication because I haven't done it in a while and it's a little rusty. So 45 times 9 is 405. So this ends up being 8 over 405 pi. And what's our unit? What is it? Feet per minute. Your height has been given in feet. Our time, unit of time, based on our volume, was minute per minute. Good. Any questions on that? Okay. Read the second one. Try to draw a picture on your own for a minute. All right, Elise, tell me one thing that we do know. Okay, so what equals 10? What? Why R? What does R stand for? It's D something, DT. What is it that's changing at a rate of 10? Someone help her out. Volume. No, that's the volume, right? Water is flowing into the tank at a rate of 10. First of all, cubic feet is an indicator of volume. And also just thinking about water filling up a tank. The volume of the water is growing and growing. So that's dV/dt. I labeled my picture with that first sentence. Find the rate of change of the depth. So what are we looking for? If we're looking for the rate of change of the depth, what would that symbol be? dD/dt. Specifically at the moment when the water is 8 feet deep. Because think about it, if you're filling a tank, is the depth changing faster earlier on or later on? Earlier, when you're kind of filling that skinnier part of the cone. Your depth is increasing very quickly, and then it starts to slow down, even though the volume coming in is the same, and is a constant volume coming in at all moments. It increases the depth quicker at first when we're only filling this much space, but then when we're up here, the depth starts increasing much more slowly. So at the moment when the water is 8 feet deep, so our depth at the moment is going to be 8. So everything is involving V and D. And so again with our volume formula, 1/3 pi r squared, can I use D instead of H because that's what we called it? Right? Are we all okay with the fact that depth and height are the same thing here? Okay. So again, if I differentiate, I'll have a dV/dt and that's fine. I'll have a dD/dt and that's fine, and not just fine, that's desirable because I know that value and I'm looking for that value. But I've got this R again that I don't want. Okay? So what do we know about the radius? It's what, Dan? Well, the radius of the top of the cone is 5. But at the moment the depth is 8. The radius is not 5. Okay? What this is giving us is no matter what the depth of the water is, let's say the water is here. What'd you say?
I said I was proportional.
Yes. It's giving us a proportion that the radius to the depth is always 5 to 12. So whatever this radius would be if the water was only filled up to there, this radius to this depth will also be in the ratio of 5 to 12. Okay? So what we have from that is that the radius over the depth equals 5 to 12. And what that's going to allow us to do is to solve for R so that we can substitute that out of there before we differentiate. Do we follow? So if I cross multiply, I'm going to get 12R equals 5D. Divide by 12 on both sides, so R is the equivalent of 5D over 12. I'm going to use that to get rid of the R prior to differentiating so that I don't have a dR/dt to worry about, because that's really not a part of the problem. So V equals 1/3 pi 5D over 12 is going to get squared. Yeah.
When you did the proportion thing, why wouldn't you just put 8 in
Because that 8 is changing. The actual tank dimensions of the fact that the radius is 5 and the 12 is the depth is 12, that's a constant ratio. But this is something that's changing. And when something is changing, I can't plug it in until after I've differentiated. Okay, the depth of the water is constantly changing because we're constantly adding water to the tank. Is that me again?
Yeah, it's a nickel and dime again, aren't they? Little here, little there.
Oh, I know what that one is. Thank you.
They don't know if you feel better, but now we're back to, I was gonna mow tonight, now it's raining.
Is it raining? Oh, shoot. You can't escape it. All right, so when we clean this up, the 5D over 12 is going to become what, Maggie? When we square it. Good, 25 over 144D squared times the D that's still there. And those numbers aren't very nice. 25 over, 144 times 3. I do too. I blame the AP people. That looks funny. Yeah, you're right. It is 432. In my defense, I did say that looks funny. I knew something wasn't right. 422 didn't feel right. Alright, so now we can differentiate. So, you know what would have been easier? No, I'm going to keep this as 3 times 144. Correct, yep. So if you don't want to multiply out things along the way, and you just kind of keep them as products, it might help you see these factors extracted a little bit easier when it comes time to simplify your differentiation, because this is going to give me dv dt, but when I bring this 3 out in front, it's going to cancel with that 3, yes? So now it's just going to be 25 over 144 pi d squared d dt. And now we can plug in everything that we know. dv dt was 10. D squared is obviously 8 squared, d dt. So if I want to kind of do it piece by piece, I can get rid of this 144, 25 over 144 by multiplying by the reciprocal. And in doing that, I can reduce the 10 and 25, yes?
Yeah.
Divide by 5, this is 2. Divide by 5, this is 5. And then I can divide by the 8 squared. And so that's going to put an 8 squared in the denominator. Maybe I'll write it as 8 times a even. And the reason I'm thinking that is because then I can reduce the 144 and the 8. They're both divisible by 4? 8. Oh, nice. So one of these 8s cancels completely. And 144 divided by 8 is 18. Yep. And then my 2 and my 8 can cancel. Well, reduce to 1 and 4. Now my 18 and my 4 can reduce to 9 and 2. So overall on this left-hand side I have 9/10. Yes? 9/10 equals, I still have the pi d dt, but I'm just going to divide that pi over, and it's going to be 9 over 10 pi equals d dt. The most complicated part is simplifying without a calculator, for sure. But I think it is more helpful if we resist the temptation to multiply out things. Just keep them separate. Make sure you're writing very cleanly, neatly, so that you don't misread something. Use as much space as you possibly can to really spread everything out so you see it clearly and you don't make a silly mistake. What? No. A right cylinder now. So we're into a cylinder, not a cone this time, a cylinder. So we'll draw that. Now the cylinder is of constant volume. It's being flattened. So as we flatten the height, what's going to happen if we have to maintain the same volume? It's going to get fatter, exactly. At the moment, its radius is 4, and the height is 5. Now that's just at the moment. Radius is 4, height is 5. Those are both changing, right? As we push it down, the height's going to shrink, and the radius is going to expand. And the height is decreased at a rate of 0.3, so dH dt is negative 0.3. At that moment, what is the rate of change of the radius? So we are looking for dr dt. So what's our formula here? The volume formula for a cylinder is pi r squared h. And so, if we differentiate this, is there any variable in there that we don't like? Maggie says V, Alex says no. Alec, why are you okay with V?
Well, we know the volume isn't changing, so dV/dt is just 0.
Yep, correct, good. So when you differentiate, these variables are all fine. We have everything we need. We'll get dV dt on the left equals, and we are going to need the product rule on the right, because we are leaving both of those variables. I see how this problem wouldn't, this ratio of 4 to 5 thing though, wouldn't even work. That ratio is not staying constant if you're flattening this shape. Yes? So like we did on this one, the ratio, we were filling up the tank, so we were always going to have similar triangles. And so that ratio was staying constant. Here, this is shrinking, this is fattening, so that ratio is definitely not staying the same. Which is fine, we don't need it because we do have all that we need otherwise. So for the product rule, we have our first times the derivative of h, dH dt, plus our second, which is h, times the derivative of pi r squared. What's the derivative of pi r squared, Bryce? L. Keep talking. Yes. Good. Are you debating whether or not to put that on there? Oh, put it on there every time. So dV dt is 0. R is 4. dH dt is negative 0.3. H is 5. Just a big game of plugging in. Pi, R is 4 again, and dr dt is what we're after. No, I don't like this. We could. I like that idea. I'll think about that. I'm not going to do it yet. She suggested changing this into a fraction. I'm just going to add this over for starters, so it's going to be pi 4 squared and a positive 0.3. Right, because I'm adding it over. Are we good with that? This is the same, oh, and you're making a funny face at me.
Yeah.
If that's the same as having the negative out in front, so when I add it over, do you see that? Equals, I mean, I could multiply this out, but again, if you don't, I'll just keep it 5 times 2 times 4 pi dr dt. And then when I divide both sides by 5 times 2 times 4 pi, our pi's cancel. Yes? A 4 in the bottom cancels with one of the 4's in the top. What else? Yeah, your 4 and your 2 is going to reduce to 2 and 1. And then, it is, I mean, even though it's a decimal, it's still a complex fraction. That's 2 times 3/10, yes? What's 2 times 3/10? 6/10. 2 times 3/10 is 6/10. And 6/10 divided by 5, aka multiplied by the reciprocal 1/5, gives me, the 6 and the 10 will reduce to 3 and 5, and I get 3/25 equals dr dt. And what is the unit on my 3/25? It's a radius, so what has our length been measured in? Centimeters. So it's going to be centimeters per, and our time has been measured in seconds. Oh my gosh, you're spent. Nope, we got one more. When was the last time we sat here for 9 minutes at the end of the class?
I think we've done it.
One?
Yeah.
Water stored in a right circular cone leaks out. Draw a right circular cone. Yeah, I don't know why they say circular. All cones, well, right makes sense because there's such a thing of like a oblique, which is like not. You remember that from geometry, an oblique? Something that's not, but a right one indicates that the altitude comes right down to the center of the base. Circular is a little redundant, I agree. Leaks out at a constant rate of 2 cubic feet per day. So what does that give us? Equals? -2. Good, because we're losing volume. Assuming the tank is 100 feet high, and the radius of its base is 25. At what rate is the depth of the water inside the tank decreasing at the moment it is 40 feet deep? Yep. So at the moment that the depth is 40, we're looking for the rate of change of the depth. So it's a volume equation, 1/3 pi r squared, I'm using d instead of h. But I have nothing regarding r or dr dt, so I do not want to go down that path. So it's one of those proportional ones, okay? Your radius to your depth always has to be 25 to 100, or 1 to 4. Cross multiply, 100R equals 25D, and we... Oh, yeah. Yeah. It is. It's funny though, because when it's a fraction equaling a fraction of my instinct, I think most people's instinct is cross multiplying, but you're right. And then divide by 100 on both sides, and 25 over 100 will become 1D over 4. Because we did not want that R there. So, go ahead and finish this on your own. And while that's happening, I'm going to bring you your homework. There are 7 questions on your homework, and the answers are written right at the end of each problem. What did you say, Dan? Seven questions?
We should. Like, one of these takes me an hour. And you gotta do the one from last night. Yeah. Good job, yeah. Really proud of you.
She's out for half day. She's out for half day. Yeah.
What?
Yeah.
They want him a
For
guidance.
half day.
How does Hank sound like guidance?
Yeah.
I thought you said you want me
A shirt for the day. I need one. I need one.
Yeah, this is $5. It was $5.
Probably right around July 4th.
No, I just, I got a bunch of t-shirts, all the t-shirts for $5. I want it like, in the middle of summer.
Yeah.
I'm like, for $5, I'm buying it for like, all these USA days.
Right. Right.
Can you tell her to sign everything on my desk?
Yes, I will. Yep.
Because we don't really have meetings, we have some issues, but I have to find more information out before I bring this issue up. Worry about it with Ally.
No, but be careful because we're being recorded.
I'm going to talk to Mike about it this series, so hopefully I'll have more information.
All right. I'll check in with you. I'll come down.
Oh, okay.
Yeah. What's that?
Have you done many things this year?
Oh, I use the cellular.
Yeah, but you said we were being